The purpose of this video is to introduce a new flood fight tool called water structures. When properly used, water structures offer the emergency manager a valuable tool for use during a flood fight while substantially reducing both deployment time and construction costs. During the next 10 minutes, we will relate through slides and video a general description of water structures, what they are made of, the theory of how they work, how they are used, equipment and personnel needs, storage requirements, and safety concerns. We will show examples where water structures were successfully used as an alternative to sheet pilings, sandbags, and earthen dikes. It's obvious that water structures do work. However, many questions, such as exactly how they work, can only be answered through testing. Some testing may require special equipment that is not normally available in the field. And testing of this nature may require the expertise of Waterways Experiment Station personnel. The manufacturer is willing to supply sufficient water structures for testing and help in the testing program if the committee so desires. Most of the testing can be completed within a 3 to 4 day period. What is a water structure? This is a cross-section of a water structure. It is made up of 3 seamless tubes. 2 tubes of the same diameter are placed inside a larger diameter tube. What are they made of? All tubes in a water structure are made of 10mm polyethylene plastic. The outer tube has been treated to resist ultraviolet light. How do water structures work? Water structures are gravity structures. To prevent sliding, the effective weight of the water structure must be larger than the external water force pushing on the structure. The resistance to sliding will vary depending on the bedding surface. Testing is required to determine the safe, effective weight of a water structure with different external loadings. To prevent rolling, the water structure is dependent on the internal friction action between the 3 tubes. When the 2 interior tubes are filled with water, they fit tightly inside the larger 3rd tube, forming a friction bond between all the tubes. When a water structure is acted on by an external force, it is theorized that the torque created by the external water force is transferred from the outer tube to the nearest interior tube. The friction forces between the 3 tubes are equal and opposite, and so prevent the tubes from rolling. Testing is required using electronic strain gauge equipment to fully understand what takes place within each tube when an external pressure is applied to a water structure. How are water structures used? Water structures are used as a positive barrier to prevent a liquid from entering or leaving a specific area. They can be quickly deployed on streets, levees, banks, lakes, rivers, estuaries, and in stream, with a minimum of site preparation, equipment, and field personnel. Water structures were used effectively to prevent flooding by local agencies in Texas and California in 1991 and 1992. Here are some examples where water structures were used effectively as an in-stream containment barrier for bank work along small and large streams. As a sediment check dam during road construction by the California State Department of Transportation. As a dewatering dike in place of sheet piles or earthen dikes to isolate work sites in channels or streams. As an in-stream diversion structure in place of earthen dikes or sandbags. As a temporary barrier to isolate work sites for channel crossings. for safe drinking water, irrigation storage, and firefighting storage in isolated areas during drought and fire season. And as a floatable boom to contain spills and undesirable floatable weeds in channels or lakes. How much equipment and how many field personnel are needed to deploy water structures? Water structures are easily transported in a small truck, van, or trailer. Required equipment includes a portable gas water pump, a Y-hose connection, enough hose to service the job site, shovels, a brush cutter, and a leaf blower for water or land deployment. Water structures can generally be deployed on a levee by 3 or 4 people. The number of personnel will depend on the size of the water structure to be used and the conditions at the work site. Some site preparation may be required before deployment, especially in unmaintained areas. Common sense should be used when deploying water structures or any structure. Additional personnel and equipment may be needed when water structures are deployed across a live stream or river. Each project should be planned and evaluated before a crossing is attempted. The 10mm polyethylene plastic is very tough and can withstand a lot of abuse without puncturing. In the event that a water structure is damaged, it can be repaired easily with waterproof tape. If greater damage has occurred or the leak cannot be found, a secondary water structure can be placed flush to the damaged one. It is important to have enough reserves to maintain the length of the structure. Storage of water structures. After the project is completed or the floodwater recedes, the water structures can be easily drained, rolled up, and stored for future use. Water structures come in different sizes and lengths. Height varies from 12 inches to 120 inches, and lengths from 50 feet to 200 feet. When the length of the water structure has been selected, it may be necessary to connect the structures with collars. This is required when the site length is longer than the structure length. The collar connections can be quickly and easily made with a minimum of practice. Joined in this manner, water structures can be extended for several hundred or several thousand feet. There is no limitation on length. Field application. Bank work along streams. Placing riprap on banks. Bank work. Dewatering of riverbeds. Construction of pipelines. Deployment time, 15 minutes to place 100 feet of a 4-foot-high water structure. Dewatering of channels. Placement of 100 feet of a 3-foot-high water structure downstream of containment area. Work area after water structure removal. Safety concerns. Water structures are versatile and can be easily deployed to and removed from the worksite. They are used efficiently by city, state, and private agencies. They have effectively contained floodwater and HTW spills and have been used as containment structures for dewatering sites, bank revetment, dredge pond levees, and storage of liquids. Water structures are cost-effective, reusable, environmentally acceptable, and safe when properly used. Most of all, water structures have the blessing of the California, Arizona, New Mexico, and Canadian Fish and Game Departments. The use of water structures is growing rapidly outside the Corps. It is to our benefit as emergency managers to fully explore the limits of water structures and provide the answers to questions that may be raised.